Everything we see today, galaxies, planets, stars, you and me, had a beginning. But what was that beginning? Was there always something? Or did everything emerge from nothing? This is one of the greatest mysteries of science, one that has puzzled the brightest mind for centuries. For most of human history, we had no real answers, only stories and philosophical ideas. But then, with the rise of modern science, we began searching for real, testable explanation. And what we found was both astonishing and perplexing. Many theories have tried to explain how our universe came to be. Some suggest universe is eternal, always existing, one form or another. Others propose cycles of expansion and collapse, a cosmic rebirth happening over and over again. And then there's the Big Bang Theory, the idea that everything, time and space itself, began from a single, infinitely small and hot point. Before we dive into why the Big Bang Theory is widely accepted, let's take a look at some of the other theories that have tried to explain the universe origin. One of the most famous alternatives to the Big Bang was the steady state theory, proposed in the late 1940s by Fred, Thomas, and Herman. This theory suggested that the universe had no beginning and no end. Instead of starting from a single point, it was expanding infinitely, with new matter continuously forming to keep the overall density constant. In 1960s, powerful radio telescopes detected something unexpected, a faint glow of microwave radiation coming from every direction in space. This discovery, called the cosmic microwave background, was a major blow to the steady state theory. Why? Because this glow was exactly what we would expect if the universe had once been incredibly hot and dense. This was the first big clue that the universe wasn't eternal but had a beginning, and the steady state theory, despite its popularity, could no longer hold up. But what if the universe didn't start just once? What if it has been expanding and collapsing in an endless cycle? This idea, known as the cyclic universe model, some suggest that the universe goes through infinite cycles of birth, expansion, and rebirth. This idea has been around since the early 20th century. Some versions of this theory come from modification of Einstein's equation, where the universe contracts into a big crunch before exploding again in another Big Bang. Others suggest that dark energy could drive endless cycles of expansion and contraction. It's an exciting idea, and some version of it are still studied today. But there's a major problem: entropy. In every cycle, disorder in the universe increases over the time. Each new cycle would start with a more and more entropy, meaning that eventually the cycle should stop. Observations also show that our universe expansion is actually accelerating, making a future collapse unlikely. There's another idea, one that takes things to an even more immense scale: eternal inflation. What if our universe is just one of many? In the 1980s, physicist Allen proposed that the early universe went through a phase of rapid inflation, expanding exponentially in a fraction of a second. But some version of this idea suggests that inflation never really stops. Instead, different regions of space keep inflating at different rates, constantly creating new universes in a vast multiverse. This idea explains many mysteries, including why our universe is so uniform. But here's a catch: it's nearly impossible to test. Since we can only observe our own universe, we have no direct way to confirm if other exist. So we have seen different theories. Some were abandoned, some still debated. But only one theory has repeatedly passed every major test: the Big Bang Theory. But why? What makes the Big Bang Theory stand out? And why do scientists believe in it? To answer that, we need to look at the evidence. The first big clue came in the 1920s when astronomer Edwin Hubble made a groundbreaking discovery. He observed that distant galaxies weren't just sitting still, they were moving away from us in all directions. And the farther away a galaxy was, the faster it was moving away. This wasn't just a random motion. It meant that space itself was expanding, stretching like the surface of inflating balloon. This was a game changer. If the universe is expanding now, that means in the past it must have been smaller, hotter, and denser. Rewind the clock far enough, and you reach a point where everything was packed in an infinitely small hot state, the very moment we call the Big Bang. But how do we know this? Is there any direct evidence that the universe was once incredibly hot and dense? Yes, and was discovered by accident. In 1964, physicists Erno and Robert were working on a radio antenna when they picked up a strange signal, a faint, constant noise coming from every direction in space. No matter where they pointed their antenna, the signal remained the same. At first, they thought it was a mistake, maybe interference from a city or even pigeon dropping on their equipment. But after rolling everything out, they realized they had accidentally detected something groundbreaking, the cosmic microwave background radiation. This radiation is a faint afterglow of the Big Bang itself, light left over from the moment the universe became transparent, about 380,000 years after its birth. The existence of the CMB was a major blow to alternative theories like the steady state model, which couldn't explain why this glow existed. The third piece of evidence comes from chemistry. If the Big Bang really happened, then the early universe should have been hot enough to fuse the first atomic nuclei together, forming the lightest element, hydrogen and helium. And when scientists measure the composition of the oldest stars and galaxies, that's exactly what they found. The universe is made up of about 75% hydrogen and 24% helium, with just a tiny fraction of heavier element. This matches precisely what we expect from the Big Bang nucleosynthesis. Others theories struggle to explain why hydrogen and helium are so dominant, but the Big Bang naturally predicts it. Taken together, these three pieces of evidence paint a clear picture. Our universe began in a hot dense state and has been expanding ever since. The Big Bang Theory is not just an idea, it's backed by observations, calculations, and experiments. In the next part, we will explore these deeper mysteries, what the Big Bang can't explain, what lies beyond. In the meantime, you can subscribe Cosmic Colors and visit channel to watch fascinating videos like this. And last, thanks for watching and subscribing.